Hey guys, welcome to my video on two-way frequency tables. This is 6-3E, the very last section of Unit 6. To start us off, we're going to take a look at a Venn diagram comparing students who are taking foreign language to students who are on a sports team. So, the one thing we need to remember about a Venn diagram is each circle represents the title above it, and the overlapping part is the area that satisfies both of those categories. So number 1 asks, how many students are taking a foreign language? So remember, foreign language is everything in this yellow circle. So what's included there? Well, definitely this 23, but also the 14 in the overlapping circle. So in order to find out the total number of students, we have to add up those two numbers to get 37 total students taking foreign language. Number 2, how many students play a sport? Similarly, sport is everything in the blue. That's the 10 plus the overlapping 14, giving us a total of 24 total students. How many students do both? Well, we know that is that green overlapping section, so that's 14. Okay, that same 14 is represented in both of the totals above. Number 4, how many students do not play a sport and do not take a foreign language? So the question is, where in this graph is that number? The kids who are not involved in either of these two. Well, if we take a look here in the bottom corner, those are all the values that do not satisfy the two categories in our Venn diagram. Okay, so that means there are 3 students who do not do either. Now, that lonely 3 in the bottom corner is not great notation. If I didn't point it out to you, you may have missed it altogether. So that's where two-way frequency tables are going to come into play. How many students play a sport but do not take a foreign language? Okay, so we're looking for how many students play a sport, so that means that it is in the blue circle. But also do not take a foreign language, so that means it cannot be in the overlapping section. So that is just the 10. So we can't pick out this information from the Venn diagram, but we do have another representation that makes organizing things into categories and looking at their totals a little bit easier. And these are called two-way frequency tables or contingency tables. And these are a visual representation of the possible relationships between two sets of categorical data. Now we can bump this up to 3 sets, 4 sets, however many sets we need, but basically it just compares the two data. So this Venn diagram that I have here on the screen is transferred into a two-way frequency table. So what are the differences? Well, on the two-way frequency table, we do have take a language and play a sport. But we also have the category of do not play a sport and do not take a foreign language. And we need that because remember, one of the questions was how many students do neither of the two? Okay, so you need an area on our table that satisfies this. Okay, so where do the numbers fall? Well, this 23, students who just take foreign language, falls in this box here, right? Well, what is this box? Well, it's the intersection, basically, of those who take a foreign language and those who do not play a sport. Okay, so that's how that information gets transferred. What about this 14, the students who play both or who do both? Well, that means should be in the column that is both take a language and play a sport. That's where my 14 is. Okay, where are the students who just play a sport? Well, look at the two categories. We have play a sport and do not take a foreign language. It falls there. And then those 3 students who do neither of the two get their own spot on the graph. They're not left out. They're not put into the corner. They have their own place on the graph. So that's the benefit of having a two-way frequency table. The other benefit is the other columns that we see. So I'm just going to erase this. We include a total column to help us understand the total amount. So remember how we asked how many students take a foreign language and we added the 23 and the 14? Well, think about this. This entire row represents, take a foreign language, so when we get to the total column, we have to add everything in that column. Okay, so that's where that value would be represented. All the students who play a sport, remember, we added 14 and 10. So our total is found at the bottom of this column. Okay, and then now that we have two other categories, we can also total those up for subtotals of their columns. So those who do not take a foreign language would be this row, the 10 plus the 3, to get a total of 13. And that those who do not play a sport is this column, 23 plus 3. Okay? Now, if you have done all your totals correctly, right, this bottom total is the total of the totals, right? Kind of crazy. Total of the totals. Meaning that if we add up these two totals up here, talking about foreign language, we get a total of 50 students, right? Because we have every student counted for. If we total up these bottom two numbers as well, we still get 50, okay? Because every category in the chart leaves no student left out, right? There is no 3 people on the side. They're included in the table. So that represents all of the total number of students that we have. Okay, so that's how we read a contingency table. That's how we fill in all the values. So what can we do with this? Well, the first thing we're going to do is construct one. Okay, so it says Felipe surveyed students at his school. He found that 78 students own a cell phone, and 57 of those students own an MP3 player. Wow, this is a dated question, right? Because for the most part, all cell phones now play music. But let's bear with me for this. Okay, so he found that 78 students owned a cell phone and 57 of those students own an MP3 player. Where on our table does this fall? Well, we have MP3 player, no MP3 player on one side of our table. We have cell phone and no cell phone. And then obviously on the side we have our totals of all the categories. So he found that 78 students total own a cell phone. So where does that go? Well, that goes in the cell phone row in the total box, 78. 57 of those students own an MP3 player, okay? So remember, this 57 represents students who own a cell phone and an MP3 player. So that belongs in this box. So without even reading the rest of the question, can we fill out any other boxes? Well, yeah. If we know there's a total of 78 and we subtract the 53 that do have an MP3 player, we get the 21 left over that do not have an MP3 player. Okay, let's move on to the next sentence. There are 13 students that do not own a cell phone, but own an MP3 player. Okay, so that 13 has two things happening there, right? Those 13 students do not own a cell phone, so they're in this row, but own an MP3 player, so they're in this column. So the 13 goes into that box. 9 students do not own either device. So that is no cell phone, no MP3 player. That 9 goes down there. So can we fill in any of the boxes? Well, yeah, we can find all the rest of the totals, right? We can add this 13 plus this 9 to get 22 total students without a cell phone. We can add this 57 plus 13 to get 70 total students who have an MP3 player. We can add this 21 plus this 9 to get 30 students who do not have an MP3 player. And then if we total across the bottom, we see that there's 100. We know we've done it correctly if the total going down is also 100. And it is. So we've done this. Excellent job. Okay, so let's take it up a notch. Let's take a look at a more challenging two-way frequency table. So the categories are still there. Okay, we're surveying students who watch sports versus don't watch sports, like pop versus don't like pop. Pause the video, read the question, and see if you can fill this table out on your own. When you're done, unpause it, check your answer. So it asked, a survey of 100 students was taken. It was found that 60 students watched sports, and 34 of these students did not like pop music. Of the students who did not watch sports, 70% liked pop music. Complete the two-way frequency table. Okay, sentence by sentence. A survey of 100 students. Okay, that sounds like the grand total, right? All the students who were surveyed. It doesn't say anything else about them. So that 100 goes in this box right here. Excellent. So it says, next sentence. It was found that 60 students watched sports. That sounds like a total to me. So we go to the watch sports column and we put a 60 in the total. 34 of these students who watch sports did not like pop music. So watching sports doesn't like pop music goes in this box right here. Okay. And then last but not least, of the students who did not watch sports, 70% like pop music. Well, a percentage doesn't give me a value that directly goes in the box. So we have to start filling in other information because we need the total of students who did not watch sports. Can we find that? Well, we know that the bottom row has to total to 100. So if I take 100, I subtract the 60 who watch sports. That leaves 40 students who do not watch sports. That's my total. Okay, that's the total represented by this sentence right here. So now what do we have to find out about these 40 students? Well, we find that 70% like pop music. So what is 70% of 40? We multiply 0.7 times 40. And we get 28. Okay, 28 students. Okay, if we divided 28 by 40, we get 0.7, which is the 70%. So 28 goes in this box. So from here, it's going to be all about figuring out the missing spaces. So we know 28 plus this box has to equal 40, so that's going to be 12. We know that 34 and 12 have to give me the total who don't like pop. So if we add those together, we get 46. We know that this last column has to add up to 100. So this box has to be 54. And that leaves, last but not least, watch sports and like pop. 26. So we could take 54 minus 28. We can take 60 and subtract 34. Either one will work, okay? To double check your work, make sure it adds up in both directions. And for this case, it does. All right. So now what else can we do with these contingency tables? Well, the other thing we can do with our contingency tables, our two-way frequency tables, is we can talk about percentages. So in the last question, we worked backwards. We had a total, and we were asked to find 70% of that total. Now, we're going to be asked what percentage satisfies a particular category. Okay, so let's take a look at this question. It says, the two-way table below shows the number of students with each hair color and eye color. Okay, so notice there are a lot more categories here. Okay, because we have to satisfy every hair color that students have and every eye color. Which is greater? So they're asking us to compare here. The percentage of brown-haired students with blue eyes or the percentage of red-haired students with brown eyes. Okay, well, what do we have to do here? Well, first, for each different category, we have to identify what's the larger group we're looking for. Because we're not looking at the percentage of total students, right? In the first question, we are asked to find the percentage of brown-haired students. So that means we're going to go to the hair column where we see brown and look at that total. Okay, that is the whole, right, of our part over whole percentage fraction. So my group I'm looking at is brown hair students, and that is 28. What is next? Well, we want to know brown-haired students with blue eyes. So again, we can only look in the brown-haired column, and we are going to go to the blue-eyed row. where these two columns intersect. Brown hair, blue eyes. That gives me 8. So if I divide 8 by 28, because we do need to convert this to a percentage, we get 0.2857, ... To convert this to a percentage, we move our decimal over 2 places, and we get 28.57%. Okay? So that is brown-haired students with blue eyes. We're comparing that to percentage of red-haired students with brown eyes. So what is my whole? What's my total? We're looking at red-haired students. That's my category. What's my numerator? Well, we want red hair, brown eyes. That's 3. So what is 3 divided by 7 as a decimal? 0.428. Okay, converted to a percentage is 42.8%. Now my rounding is slightly off, but it's just asking me to compare. Okay, so which one's greater? Well, the percentage of red-haired students with brown eyes is greater than the percentage of brown-haired students with blue eyes. Okay, so again, something we can do is go by individual categories and find smaller percentages for smaller groups within the larger group. So let's try one more. The school newspaper surveyed the student body for an article about club membership. The table below shows the number of students in each grade level who belong to one or more clubs. Okay? So before we even look at the question, what's different about this table compared to all the rest that we looked at today? It doesn't have the totals column. Okay? Now we could find all of these totals column, or we can wait to see what the question asks of us so that we can identify just the total that we need. Okay, so let's see. It says, if there are 180 students in the 9th grade, what percentage of the 9th grade students belong to to more than one club? Well, there we have our total, right? The total number of students in 9th grade. That is the total of this top row, 180. What percentage of the 9th grade, so we're staying in this row, belong to more than one club? So what satisfies that? 2 clubs and 3 clubs. Okay, so what are we going to do here? Well, there's 33 students who are in 2 clubs and 12 students who are in 3 or more clubs. When you add those together, we get 45. Okay, so there are 45 students in more than one club. Out of the total of 180, because again, we need a percentage, we can divide, convert to a decimal, and take that decimal and convert it to a percentage. Okay, so 25% of 9th grade